Okay, the third example I'll give you is electron capture. Electron capture happens to nuclei that are big and have too many protons. Now, the nucleus, in order to go through electron capture, has to be fairly large. Why is that? Well, the reason is, here's my little electron. Let's imagine this is an electron, tiny little particle, and it's flying around. So you know that an atom is composed of an electron cloud around the outside and the nucleus at the center. Well, imagine an electron wandering around nearby the nucleus. Every once in a while, if the nucleus is fairly large, the electron might wander right through the nucleus. So this actually happens all the time. A big, heavy nucleus has enough space inside it that an electron can fly right through it. If you have a nucleus like hydrogen, which is just one proton, there's almost no chance the electron is ever going to hit it. But the bigger the nucleus is, the more times the electron is going to pass through it. The more often an electron is going to pass through it, and the more likely it is an electron will actually get stuck inside the nucleus. So this is what's going to happen. So for this example, I'm going to pick oops, I'd forgotten to finish counting my nuclei. So what I put here is 24 protons, so Z equals 24, 24 neutrons, so N equals 24, and the total A is 48. So there are 48 protons and neutrons here. So this is a reasonably big nucleus. And if I look on the periodic table, I find that the symbol for this atomic number 24 is chromium, Cr, and I write 48 chromium for that isotope. Now, let's imagine that an electron comes wandering around and whoosh, goes into the nucleus. So I'm going to take the 48 chromium plus an electron, and what do I get? Well, what happened to the charge here? The charge went from Z equals 24, I had a plus 24 charge here. Afterwards, I'm going to have a daughter nucleus, well, I had a plus 24 charge, but then also I had an electron. That brought some charge in. And the electron charge is minus 1. So if I add up the charge of the nucleus here plus the electron that got stuck inside it, then I'm going to have 24 minus 1, which is 23. So the daughter nucleus had better have Z equals 23. How do I show that? Well, here's how I can do it. I can imagine putting this negative charge in here. And what will happen if I stuck that negative charge onto a proton? Well, I get a negative charge and a positive charge. And if I add them up, actually, I get 0. So I can take this out and replace it with a neutron, and that is actually what happens. The electron gets stuck in the nucleus and combines with a proton to make a new neutron. So now you have Z equals 23, so that's 23 protons, and one of those protons that was here got turned into a neutron, so N now is 25. A is still the same, so just like beta decay, A doesn't change. So then A is still 48, and you can look on the periodic table and say the daughter must be 48V, which stands for vanadium. So this is an example of electron capture. So you can think of the electron as something which is almost no mass, but it carries the negative 1 charge. When it gets in there, it reduces the charge of the nucleus. To reduce the charge of the nucleus, it takes away 1 proton and turns it into a neutron. So then you have, Z equals 23 and N equals 25. Okay.